I'm preparing for the motor testing of the compressor testing. So most likely the color of this cable, there's a 3 wire here. This is 1.5 millimeter wire gauge, 3 core or 3 wires inside. So this is the color RYB. No. Yeah, tama. Yes, correct. RYB. So this is red, yellow, blue. Okay. Mostly in the color code of the power supply, power source, the power cable, yeah, is RYB. Mostly in the main breaker in main transformer, main power source. Most likely the color of the cable is RYB and B. Red, yellow, and the B blue, and other one B is black. Mostly the neutral connection is black, and the live wire, this 3-phase power supply or 3-phase cable is every phase is there's a power supply or there's a voltage. So the phase 1 is R, this is live wire. Phase 2 is yellow. Phase 3 is blue. So this is 3-phase power supply. Okay, and the big cables, and the other one is ground. Most likely is green stripe of yellow striped by green, and the other one is black. That is the connection for the neutral, which I used to here for testing. I follow this connection. Will follow this connection. R is the common. Okay, R is the common in the compressor. It means the phase 1 or live, but we cannot identify the live and neutral here. So we just follow this color code because this is AC power supply. Even we inverted this one, the same, it will complete circuit as long as the connection from the capacitor is in correct connection in correct position. But here, even inverted, or maybe here the line, maybe here the neutral, it will complete circuited as long as this capacitor is the same connection or in the proper connection. So we finish already. We need to cap. This is wire cap, wire nut or wire cap. The next is this yellow is put in running. Okay, running. It means it can be live or neutral. It depends the power source. So this But we can determine when we use a tester, multi-tester or tester, voltage tester. But when we plug in, we cannot identify where is the live or with which one the neutral. So, but we can follow here. So the other connection, the yellow, either line or neutral, we can connect as long as we always follow the color code. So we use the yellow for the running terminal leads for the compressor. So if running, this is red. Okay. Now the next is so we need to install also the terminal leads for the capacitor. We use the yellow, so we need to use also the yellow here for the capacitor. We need yellow, so we will cut here. No. Blue. We need to cut the blue because this is for the capacitor, okay? So we need to install or connect our terminal leads for the capacitor for running. So I use this blue because this is still blue here, but this is running from the yellow. Okay, now complete. This is the starting and this is the running. So we install the terminal clip for the capacitor. Take note, some capacitor is dual capacitor. There's a 3 terminal post. The center is the common running or the compressor or herm or compressor, and the other one is fan F. So this is 2 terminal post only. That's why even you interchange either this one, the running or the starting, it doesn't matter. There's no problem for this. But the problem is if we have a 3 terminal post, that is a big problem if you interchange the connection. So it doesn't matter if what color we use here, as long as the same connection, the running is connected here and the capacitor, the starting is connected here also. don't connect in one terminal post because it will burst. It will short circuit or it will damage the compressor. Okay. Now I install now the terminal clip. When installing the terminal clip, we need the crimper, wire crimper, but this plier is have dual purpose. It have a wire crimper. Check, there's a wire crimper. Also with here. So complete, there's a terminal leads for the starting and running connection for the capacitor. So I will connect now. Check, don't connect in the same post. Always this one have a gap or separate post. Don't be in hurry. Always check and always observe which connection you connect. Maybe it will if interchange or mistake, it will burn or it will burst. You will damage the compressor. This compressor is expensive, so you lost big money. Okay, wiring connection is completed, so ready now to test. Although we don't have a male plug, we can test directly for short time or a few seconds only. And take note, we need to read the current flow or the current. Suppose it will not exceed in the required or in the detailed ampacity or amperes. I'm preparing strap of this capacitor temporary so that we can test properly. I'm in our workshop, mechanical workshop, and I am the one who in charge in this department or this section, the electronic or the mechanical HVAC department. My experience in this field, maybe it's been a long period, but it's still learning, because I didn't tell myself, or I didn't consider myself as a perfect person or expert person. still I consider myself as a learner. Alright, double check. This is the supply line. So we use the red and yellow. So this is the power source. So we need to identify which one the compressor and the common and the running. The common and running is the power leads that is supplying this compressor. That is the power leads. And the starting leads is to start only high torch, so that this compressor it will start fast and very easy to rotate or to energize and to work the pumps. So upon starting, it will breaks only inside the capacitor is there's a contact inside. Upon starting, if we energize, start, contact and breaks, then flow directly the voltage. If required 220 volts, only 220 volts will use for this compressor. But in starting, this capacitor is storing voltage inside, storing until 450 volts stored, so that it will very fast start, and after reach the starting torch, it will break. So it maintains the 220 volts. That's why we need capacitor. We need to sustain the 220 volts. Okay. If we don't have capacitor, when starting this compressor, it cannot reach the 220, only 110 like that. It flows only 110. The voltage is only 110 entering to this compressor. So it cannot start the compressor. So we need the capacitor to start the compressor to sustain the 220 volts need in this compressor. Alright, now ready? We need to remove the cap of the discharge. And if a brand new compressor, there's a pressure inside. So we need to check that it's not broken. It will seal. It's still sealed. If there's a pressure, it is sealed and it's brand new. Small pressure. Another side, this suction or this return line or suction line. Okay. We need to protect this one because it will suck. We need to protect and put a filter. A full filter or screen so that will not suck dirty or foreign objects from outside, because this dirty air, if coming foreign objects or some dust going inside the compressor, that the one source or cause of stuck up. So the next is we need to use flamimeter. What is this? This is a flamimeter. So there's a selector here. This is the amperes. This is the ohms or resistance, and this is the voltage. Put AC. There is no direct current here. So I position to amperes. So suppose this is coming only 20 amperes maximum. We will only position the minimum because this is 400. This is the minimum. Okay. Now ready. If this compressor blows with oil, this is not a good compressor. So suppose there's no oil pump. So to use this thermometer, in between the line, power line, we clamp this so that we can read the current flows in this line. So ready? This is okay. Now start. This one discharge, no oil pump. This sucking or suction side, it's sucking. The nominal or the start capacity or current flowing now is 7.9, 7.7 below, and the maximum is current for this compressor is in a full load amperes is between 16 to 18. So, but it maintains the 0.15. This is good running condition. And exceeding in excess to 18 to 20, the compressors is a hard working or hard it's hard to work, it's hard to run. Now only 7. So the maximum, if in full load condition, this one is running 13 to 15. Alright? So it will not fluctuate the current. Stay on 7.9, 7.8. It will not rising up. It will also down to 7.7. So stop. We can stop now because this is now good. Okay, thank you.